So far we have learned three types of proofs: two-column proofs, paragraph proofs, and flowchart proofs. There's another type of proof that is extremely powerful, and that is a coordinate proof. So in this video we are going to do a simple proof using coordinate geometry. Before we start, however, there are a few things that I would like to remind you of concerning coordinate proofs, namely what they do well. We have three very powerful tools to use on the coordinate plane, the first being the slope formula. Using the slope formula, we can determine if lines are parallel, and we can determine if lines are perpendicular. Next, we have the distance formula. Using the distance formula, we can determine if segments are congruent, which allows us to determine if sides of figures are congruent and all of that fun stuff. And finally, we have the midpoint formula. Obviously, that allows us to find midpoints, but it also allows us to determine if segments have been bisected. Now, there are some things that coordinate geometry does not do well, and that is angle measures. It's very difficult to determine if angles are congruent, if they are supplementary, unless you have a linear pair, and if they're complementary, once again, unless you have adjacent complementary angles, because then you can use perpendicular lines. So we try to avoid angles and congruent angles in coordinate geometry. But that's okay, because we have plenty of tools that allow us to just work with the sides of figures to prove that they are congruent. So let's get started. Let's prove that the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. Yeah. Okay, let's break this down into what we are given and what we need to prove. Now we are given that we have a right triangle, let's call it triangle OPG, and a midpoint of the hypotenuse. So let's say M is the midpoint, and let's make segment PG the hypotenuse. So what does that look like on the graph? Well, here we have triangle OPG. Notice how, because it's a right triangle, one side fits along the y-axis and the other side fits along the x-axis. That makes it very nice. And we have labeled the hypotenuse as segment PG, so we have point M, that is the midpoint of segment PG. Now, because we know we are going to be using algebra, and we know that the midpoint requires us to divide things by 2, let's choose coordinates for P and G that are easily divisible by 2. The x-coordinate of P, of course, is 0. The y-coordinate will make 2P. And likewise for G, the x-coordinate is 2G, and the y-coordinate is 0. And the zeros come because they're on the various axes. Alright, so now we have our figure, we have it labeled. What are we trying to prove? Well, we are trying to prove that the distance from O to M, the distance from P to M, and the distance from G to M are all the same length. So now let's get started. We'll start by using the midpoint formula to find the coordinates of M. And that's really easy to do because you add your x-coordinates of P and G, divide them by 2, add your y-coordinates of P and G, divide them by 2, and you find out that the coordinates of M are G, P. Now that we have the coordinates of all of our points, let's talk about what we know. Well, since M is the midpoint of segment PG, by definition of midpoint, we know that the distance from P to M and G to M are equal. That'll be helpful, because now we need to use the distance formula. And because we know that PM and GM are already equal, we only need to find one of them. Let's start by finding the distance from O to M. That's simple because we just take our x-coordinates, subtract them, and square them. And our y-coordinates, subtract them, square them, add them together, take the square root, and voila, we are done. Now, I have a lot of students who say, well, isn't that G plus P? No. Remember, the order of operations requires us to do everything inside grouping symbols, and we have to do the G squared plus P squared before we can take the square root. Since G squared and P squared are not like terms, we can't add them, so we cannot take the square root. But that's okay. Just leave it like that. That's as simple as it goes. And now let's move on to another segment. Let's find the distance from P to M. Again, we'll take the x-coordinates, subtract them, square that. Take the y-coordinates, subtract them, square that. That tells us that we need to square the opposite of G, and we need to square P, add them together, take the square root. But wait a minute, with the opposite of G, If you square a negative number, you get something that's positive. So therefore, when you square the opposite of g, that's the same thing as squaring g. Notice now that the distance from O to m and the distance from p to m are equal. They both equal the square root of g squared plus p squared. And we also know that gm is equal to pm, so the transitive property tells us that all three segments are the same length. And we're done. So notice how quick that was. We used the midpoint formula once, the distance formula twice, and the transitive property. Boom. Simple. So that's an example of a very straightforward and simple proof using coordinate geometry.